Okay, welcome back, geometry students. This is section 10.5. We are learning more about angles and arcs in regards to tangents and chords going through a circle. So we have 3 theorems on this study guide, Theorem 11, 12, and 13. And I like the way they're described, but I wish they had a pretty picture to go with them. So I actually went into our textbook and I kind of added a page here to our study guide notes. So let me get to that. This goes over our theorems a little better, I think. So this first one up at the top is Theorem 11. We're just going to look at this one for right now. Theorem 11, or they say 10.11 because it's chapter 10, Theorem 11. If a tangent and a chord intersect at a point on a circle. Okay, remember, let's remind ourselves here that tangents are lines or rays or segments, whatever, but they are on the outside of a circle, but they just intersect the circle at one point. Okay, that's what a tangent is, intersects the circle at one point. And chords, remember, are segments whose endpoints are on the circle. The chord goes through the center, the interior of a circle, but the endpoints are on the circle. A secant is a line that cuts all the way through a circle. Okay, so it's like the chord is a segment, a secant is a line that goes all the way through. It keeps going. So anyway, just a few little reminders there. So it says if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so I like the different colors here. It saves you from me having to draw it. So here they're saying on this one, measure of angle 1 is 1/2 the measure of arc AB. So here's arc AB. Here is the measure of angle 1. We're talking about this being our angle 1 measure. Okay, so if the angle measure is 80, then the arc measure is going to be twice that. If the arc measure was 70, then the angle measure is going to be half that. So it's going to be 35. That's what we're talking about. Okay, and it works both ways. So if you look over here on this side, okay, measure of angle 2, that's this angle. Okay, measure of angle 2 is 1/2 the measure of arc BCA. So that's the major arc. Remember, we had major arcs and minor arcs. Major arcs are greater than 180. Minor arcs are less than 180. Minor arcs, they just use 2 letters to name them. Major arcs, they use 3, so you kind of know what direction you're going around a circle. So 2 is 1/2 the measure of the arc BCA. Okay, so again, I like the different colors on this one. That's why I chose to look at that. So now I want to go back. I'm just going to look at Theorem 11 for right now. Okay, let's go back and do some example problems. Then we'll come back to Theorems 12 and 13. So look at these examples, first of all. It says line X is a tangent to the circle. Find the measure of angle 1. Now this is part A. Well, first of all, this arc measure is 220. That's the whole arc. Okay, so the measure of arc JLK looks to be 220. Okay, so we are trying to find the measure of angle 1. Okay, so measure of angle 1 is going to be 1/2 of that intercepted arc. So 1/2 of 220 is 110. Okay, again, they did the work for us, but I just kind of wanted to write it off to the side. Now, going the other direction. If they give us the angle measure, we should be able to find the arc measure. So here they're telling us that this angle measure, this right here, is 135. So now we are supposed to find the intercepted arc measure. Okay, so it's going to be twice that. Okay, or 270. Okay, That's what we're looking at. And I think one of the examples I'm going to do down here below, it'll be even a little easier to see. I'm actually going to start with number 3 down here, because I think this clearly shows you why it is, why the angle is half of the intercepted arc. So here, if we look at number 3, again, want to do it first. So this angle right here, they have is 90 degrees. So it's perpendicular. Well, you can see if it's 90 degrees, looks like this cuts the circle in half, right? If that's 90 degrees, first of all, do you remember that a tangent is 90 degrees to a radius of a circle? We learned that in a previous section. Well, that means that essentially the center of the circle would have to be right around in here somewhere. So that makes this XZ chord actually a diameter. Okay, so XZ is a diameter of the circle. Okay, well, if that's a diameter, then that means the intercepted arc is a semicircle. So that's 180. So you can obviously see then that the measure of arc XZ is 180 degrees. So I wanted to kind of start the exercises with that one because I think that's the little easiest to see. So you can clearly see that if the angle measure is 90, again, this is 90 degrees. So the semicircle here is 180. Okay, I think that's a little easier to see then. Okay, that's why the angle's half the intercepted arc. Okay, now let's go back and look at 1 and 2. So here on number 1, they want us to find the measure of the arc PRQ. Now you can already tell that it's a major arc. They use 3 letters to define it, right? Or to name it, if you will. So arc PRQ is what we're trying to find the measure of. This 113 degrees is for this angle. Okay, 113 degrees is for that angle. So essentially, the measure of arc PRQ is going to be twice that. Okay, so 226 degrees. I hope you guys see that. Okay, now, number 2, they want us to find the measure of angle 1. Let me use a different color this time. So they want us to find measure of angle 1 here. Okay, but they tell us that the intercepted arc here is 164. That's the arc measure. Okay, so our angle measure, okay, so measure of angle 1 is 1/2 the intercepted arc, or 1/2 of 164. So it's going to be 82 degrees. Okay, I hope you guys can see that. All right, that pretty much takes care of Theorem 11. That was the first theorem on our study guide. Okay, first theorem. Now, let's look at 12 and 13, and let me go back to that second page I added here. So 12 and 13, let's look at those two. Here they are. So Theorem 10.12, or Theorem 12 in Chapter 10, if 2 chords intersect inside a circle, which by definition, if they're chords, they're going to intersect inside a circle, but then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Woo, okay, so here's what this is telling us. Measure of angle 1, you can see this here in the color, okay? Measure of angle 1 is 1/2. Now, I want to point out here that the 1/2 is outside the parentheses, okay? 1/2 the measure of arc DC plus the measure of arc AB, okay? 1/2 of that sum. Okay, again, want to point out the parentheses. Same thing with angle 2 now. Angle 2 is 1/2. Again, notice the parentheses. 1/2 AD, okay, plus 1/2 BC. I'll have to do both of those in purple since I've already used the red and the blue. So 1/2 AD plus, or sorry, 1/2 the measure of AD plus the measure of BC. So again, intercepted arcs. Okay, that's theorem 11. Now, theorem 13 is very similar, but we're talking about external angles outside of a circle, and then it's going to be 1/2 the difference. So if you look here at theorem 13, if a tangent and a secant, two tangents or two secants, okay, again, let's remind ourselves, tangents just touch the outside of a circle in 1 point. Secants go through a circle and touch it in 2 points. Okay, so you can either have a secant and a tangent, two tangents, or two secants. Outside a circle, then the measure of the angle formed by those two things, either the two tangents, the two secants, or tangent and secant, is 1/2 the difference of the measures of the intercepted arcs. And again, I won't necessarily go over these because they already have pretty colors. I don't want to mess it up too bad, but this is 1/2. Again, I want to point out the parentheses and I want to point out the minus. Okay, so measure of angle 1, that's this angle right here, is 1/2 the difference of this arc minus, I said I wasn't going to color over them, I'll do it beside them, minus that arc. Okay, 1/2 the difference. And does it matter which one goes first? Yeah, the bigger one goes first. Okay, because if we're going to measure things, we can't have negative angle measures, okay, or negative distances. Same thing with angle 2. Angle 2, again, want to point out the parentheses, point out the minus, okay? It is 1/2 the measure of this outside arc measure minus the measure of the inside arc that's intercepted. 1/2 the difference. Okay, now if you have two secants, same thing. Angle 3, I want to point out again the parentheses and the minus sign. Okay, the bigger arc minus the smaller arc. 1/2 that difference gives you the angle measure. Okay, so I added this page to your notes on purpose because I liked the different colors, liked what they were saying, liked that you could maybe see it a little better. So let's go forward here, the back side of your study guide. Let's look at some examples. So example 2, find an angle measure inside a circle. So find the value of x. So this is x right here. Okay, well, the two angles that x and its vertical angle intercept are this angle and this angle. Since the two chords intersect to form interior angles, then it's going to be half the sum. So again, x degrees here is half the measure of AC, which is 85, plus measure of BD, which is 57. You can see that clearly here, 85 plus 57. 1/2 of that sum, okay, if you do 85 plus 57, you get what, 142? 1/2 of that is where they get the 71. Okay, so x is 71. Again, if it's interior, it's 1/2 the sum of the intercepted arcs. So now number 4 says use the diagram in example 2, find the value of y. So now y is this arc, okay? Sorry, that angle. So it's dealing with these intercepted arcs right here, okay? So y is going to equal 1/2 the sum of the measure of arc CB plus measure of arc AD. Okay, well, that is 1/2 of 148 plus 70. Well, 148 plus 70 is what, 118? So 1/2, no, sorry, 218. Excuse me, equals 109. Okay, so y is 109. Hope you guys see that. Okay. Now, let's look at these external angles here in example 3. It says find an angle measure outside a circle. So part A, we're dealing with two secants. Okay, so again, we are looking for angle X, and the two arcs that get intercepted are the PR and the SQ. And this is 1/2 the difference. So if you're looking for the measure of an angle outside the circle, then it's 1/2 the difference of the intercepted arcs. Okay, so 1/2 of arc PR minus measure of arc QS, and that's where they get the 45. Okay, now on part B, we're talking about a secant and a tangent. Okay, so again, we're still looking at measure of angle X, and again, here's our one arc, here's our other arc. Okay, so they've got here 1/2 the measure, again, parentheses. Don't forget the parentheses. I probably should have pointed them out up here as well. Don't forget the parentheses. It's probably one of the biggest mistakes I see students make. And it's minus if it's an external angle. So 1/2 the measure of EG minus the measure of ED. Again, you're just taking the bigger one minus the smaller one. Because we can't have negative angle measures. So X is 70. Now let's look at our examples here. Actually, I guess we just have one example. Okay, so here we have two tangents. Okay, so we're looking at the measure of angle 1, and the two intercepted arcs are this and this. Okay, I should have used different color. So this, and again, this. Now, notice that those two arc measures, the 140 and the 220, add up to 360 because we're dealing with two tangents. Okay, so none of the circle is left, all right, because they're tangents. The tangents are just going to touch the circle in one point. Okay, so measure of angle 1 is going to equal 1/2 the measure of arc BDC. It's a major arc, so I need 3 letters. Okay, minus the measure of arc BC. Okay, again, it's minus because it's an external angle. If they're chords that cross in the middle, then it's half the sum. So this is 1/2 of 220 minus 140. Okay, that is 1/2 of what, 80 or 40. That's our answer. Of course, got a couple of dead spots there. Okay, hope you guys see those. Let me try to scooch the board so I can fill in the dead spots. Okay. All right. Now, let's look at our practice A and do a couple together. Okay. So here's our practice A. I'm just going to kind of randomly do some here and there. So number 1, find the measure of each numbered angle or arc. Now remember, our first theorem for this section was that if a tangent and a chord intersect at a point on the circle, then the measure of the angle formed is half the measure of its intercepted arc. So this 172 here on number 1, that's the measure of the arc, 172. So we are trying to find the measure of the angle, I can't even draw a straight line, angle 1. Okay, we are trying to find this. So remember, measure of the angle is 1/2 the intercepted arc when you have a tangent and a chord. So measure of angle 1 is 1/2 172. So that's going to give us 86 degrees. Hope you guys see that. And that makes sense based on the picture. 172 doesn't quite look like a semicircle, okay? And then of course half of that isn't quite perpendicular. Number 4, same kind of deal, okay? Only this 82 is for here, and we are trying to find the measure of arc 1, okay? So, oh, and let me back up here. It says find the measure of each numbered angle or arc, okay? So we've got to find number 1 and number 2. So number 1, measure of, I shouldn't say angle 1, I should say arc 1. Measure of arc 1, okay, is going to be twice the 82. So 164, okay? Well, that line on the outside is a tangent, okay? So this tangent is again just touching in one spot, right there. So what do you think arc 2 is going to be? So the measure of arc 2 is going to be 360 minus 164. Hope you all kind of see that. So this would be 196. Okay? Because together they add up to the 360 for the circle. Okay, number 7. I'm just kind of going straight down here. Now, a couple of things here on number 7. We're going to use that Theorem 11 that says that an interior angle formed by two chords intersecting is half the sum of the intercepted arcs of that angle and its vertical angle. So what they're telling us here is that this arc and this arc added together divided by 2 equals this angle. Okay, so let me kind of set that up. So 47, they already gave us the angle measure, equals 1/2 the sum of those intercepted arcs. So that is 41 plus arc 1. I'll put measure of arc 1. Okay, I hope you all see that. Okay, so I'm going to get the half off of this side by dividing both sides by 2. So this is going to give me 94 equals 41 plus measure of arc 1. Okay, it almost looks like an M with the upward arrow. That's supposed to be measure of arc 1. So then if I subtract the 41, of course I get 53. So measure of arc 1, whoops, is 53 degrees. Hope you guys see that. Okay. Now, what would number 2 be? Several different ways we can do this, but honestly, the most straightforward way to find number 2, if this is a chord, that means it's a straight line. That means that measure of angle 2 plus 47 degrees has to equal 180 degrees. Those are supplementary. They are a linear pair. Okay, so that means that the measure of angle 2 is 133. Okay, I hope you guys see that. So angle 2 and 47 degrees form a linear pair. I'm going to skip down. Let's do 15 together. Okay, so again, this is an external angle. Okay, so we've got a couple of things going on here first. Before we can find number 2, we need to find number 1. Now, we've got these 3. We've got this arc, we've got this arc, we've got this arc. So how would I find the measure of angle 1? Okay, measure of arc 1, I guess I should say, is 360 minus the sum of all of those. 105 plus 130 plus 70. So that's going to leave us with 55 degrees. Okay, so let me write that in here. This is actually 55 degrees. Okay, now if that's 55 degrees, how do I find the measure of angle 2? Well, measure of angle 2, because it's an external angle, okay? Measure of angle 2, remember, is 1/2 the difference of the two intercepted arcs. So that's going to be 130 minus 55. Okay, poke that in the calculator, yada, yada, yada. I get 37.5 degrees. Okay, so that is my number 2. This is my number 1, and you can tell where I have a couple of dead spots on the board. Okay, let's go to the next page. Backside here. More of the same, okay? So let's look at 16. 16, now we are trying to find, first of all, the 180 is going from here around to here. Okay, that's obviously a semicircle. And then this is the other intercepted arc. We're trying to find the intercepted arc, one of them, when we're given the angle measure. So again, got to make an equation here. So 38 equals 1/2 of 180 minus x. Okay, well, multiply both sides by 2 to get rid of the 1/2. So this is going to be 76 equals 180 minus x. Okay, I hope everybody saw that. Let me just put, here's what I did. I don't think I wrote that on the other side either, but we are multiplying both sides by 2, and then those 2's cancel. That's what I'm doing there. Okay, so then 76 equals 180 minus x. If I solve for x, it's 104. Okay, actually, since it was x degrees, it should just be 104. I shouldn't need the degree symbol, but either way is fine. Let's look at 21 real quick. 21, we have 45. First of all, a couple of things. Let me back up. If this right here, remember these are tangents, first of all. Okay, you can see that my 2 sides of my angle here are rays are actually tangents to the circle. Okay, so they're just hitting the circle in one point. So if that is x, that means what's left is the entire rest of the circle. This would be 360 minus x. I hope you all can see that. Okay, so if that's x degrees, then this is 360 minus x degrees. Okay, because together, 360 minus x plus x, the x's would cancel, they should add up to 360. Okay, so again, same kind of setup as we had previously on 16, but we're going to have 45 equals 1/2 the difference. Remember, we're subtracting here because it's an external angle. 1/2 the difference of 360 minus x minus x. Now, I know I have kind of like big parentheses or little parentheses inside bigger parentheses. I should have used brackets, but. So this, again, I'm going to multiply both sides by 2 to get rid of the half. So 90 equals 360 minus 2x. I hope you guys see that. So then I essentially get 2x equals 270, x equals 135. Okay? Hope you guys see that. Now, I don't want to spend a whole lot of time on 22. I didn't really like the picture or the way it was explained, but here's my tip to you. So this is where the satellite is, and here's the point T and the point R that are on the Earth, okay? And we are trying to find this arc measure, okay? Well, you'll notice here that they also tell us, they kind of draw these triangles, okay? So you'll notice that those are right triangles. So U is just an external point, okay? So UR is perpendicular to RS and UT is perpendicular to TS, okay? Maybe I ought to make those purple, okay? It's part of that triangle. Now, what they're saying then, if I cut one of these triangles and pull it out here, that this is 4,000, and they're saying that this length is 8,000. Well, if you remember, we had a triangle, okay, where this was a 1, this was a 2, this was a √3, okay, and it doesn't, we don't really need to know that length, so it doesn't matter, but that's a 30, 60, 90 triangle. This was one of our common right triangles, okay, that we used in some of those trig functions, okay, 30, 60, 90. So that means that this angle right here is 30 degrees, as is that angle is 30 degrees. Okay, so altogether, measure of angle RUT is 60 degrees. Okay, measure of angle RUT is 60 degrees. That's going to be my hint to you. Okay, that's going to be my hint to you. So one other thing I would show you is that this, kind of picture this as being extended, okay? And then I'm going to leave it alone. Okay. All right. I think I'm done then with section 10.5. Hope this helped. I will have everything posted.